Hi guys, meteorologist Lindsay Slater here. I'm not sure if you're aware, I also do have a space weather certificate, so I thought this video could just be about what I'm looking at when it comes to space weather. So, um, I got my space weather certificate from Millersville University. I recently graduated in 2025, also with my master's in emergency management. And I wanted to talk about space weather because you might be thinking, okay, the vastness of space, there's nothing going on there. There is so much going on in space. Like, it is insane what is out there. There are coronal mass ejections, these big chunks of plasma that come out of the sun, and that's what gives us geomagnetic storms. But there's also radiation storms. We have particle events that come out, and it's a very specific way to find out if we have auroras. You're not going to get auroras from a solar flare. That is really just going to cause radio blackouts, which becomes important because when you're in the middle of maybe hurricane devastation and you have a solar storm, or you have some kind of radiation storm from a solar flare, if that's happening at the same time, you might not have communications. And that's why I thought this was a very important part of what I do to study it, because I might be in a situation where I'm covering tornado damage and then the emergency managers can't get a hold of anybody because we have an R3 radio blackout. Their scales are 1 to 5, by the way. So over the last 15 hours, we actually did have a G3 level storm. So things are categorized from 1 to 5, kind of like tornadoes and hurricanes. So a G3 level storm, this affects power systems, spacecraft operations. So what happens when you have a G level storm? This is when you have plasma coming out of the sun, or a coronal hole, which is it's a lot to explain, but you can get coronal holes in the sun. It looks like big black chunks of the sun taken out. And this creates high speed streams that launch themselves toward the sun. That can actually cause low level auroras, but it also can cause G2 or 3 level storming, which can impact the power systems, the power grid, and it can cause basically those transformers to fail because they overheat. So I wanted to show you kind of what I'm looking at. This is just a couple of websites I use, but over the last 15 hours, this was issued May 29th at 2:16 UTC. So that's basically the same as Zulu time. It's universal time. And that basically happened like at, 8, 9 o'clock last night. So this message was showcasing a G3 level storm. When you're looking at SWPC, which is the Space Weather Prediction Center, be very cautious on this auroral oval. It's just a weather model and it's absolutely terrible. So don't look at this and say, oh, wow, Wisconsin's going to get some auroras. We did not get auroras. And not every storm is going to bring auroras. The right things have to line up. So this G3 level event was observed. It happened. And again, look at the bottom here. It says due to a coronal hole high stream. So I'm going to zoom in so you guys can see that a little bit here. Whoops, I don't know how to do this. There we go. Look at that. Negative polarity, coronal hole, high speed stream. That's exactly what I was just talking about. High speed stream from coronal holes. So it wasn't from plasma coming out. It was from a coronal hole. What is a coronal hole? Well, you can see it on this map. Here is a look from SDO. Which is one of the spacecraft observatories. And you see this big gaping hole right here. Let's make it bigger. You can see it right here. That is a coronal hole. And then this is specifically the 193 angstrom wavelength. This is a really good one to see coronal holes. The 211 is really good to see coronal holes, which is what we call the pink sun, which is right over here as I highlight here. The 304, that's good to see certain other things like filament eruptions. But this one specifically is also good. You can see some solar flaring going on right here, right there, and likely over here. There's a very active sun right now as we are on the descending phase of solar cycle 25. You can get a lot of storming on the descending phase, and actually you can even see some, I feel like those are filaments. So let's go take a peek. Yeah, you can see that right there. Little, I think those are filament eruptions. There could be some right there and also right there, these little dark spots. Very active region right here as well. So I'm literally just showing you because I think data is really cool. This is the 211 angstrom, and yeah, you can see this is a very, very long coronal hole, and what it does is it's pushing solar wind, which is wind in space, and it's pushing it towards Earth. And as long as it's Earth directed, we could get some minor aurora out of it. But in this case, we got some G level storming going on. The solar flare sun you want to look at is the 131. This one shows really good quality of flaring, which you see some right here. Over here, this is a pretty decent active region as well. So looking at the solar synoptic map, this is from SWPC. Right there, this one is the one I was just talking about, and you can see This one has a 60% chance of a C class flare, which is like the lowest tier, and then you get up to M and X class. This one's got a, I think that says a 20%, nope, 5% chance of X class. So this is a pretty interesting one to kind of watch for. Here's another one as well. So yeah, pretty cool looking at this data. With that being said, no, we didn't see Aurora last night because it was cloudy overnight. I will always post when I think we have an opportunity to see Aurora, and it's very finicky because you can watch a coronal mass ejection happen, and you can watch it on the sun's coronagraph, which is basically like looking over the sun. You can see it launching. If it's not earth directed, if it just glances us, we really don't get a lot of storming going on. So we only know that when it hits other spacecrafts on the way here. So yeah, let me know in the comments if you guys like a little bit of this space weather stuff. I'm trying to keep the information nice and solid in my brain. Another thing we look at are all this data. Oh yeah, it was a lot to learn. I thought meteorology was hard. Space weather is a whole other thing. BT right here, that is this little guy. This showcases storming, overall storming, and we did have a peak right here with a big drop in BZ, which is the southern magnetic field component. Those two together showcase at the same time the temperature increased and the solar wind speed increased, which tells me this is a high speed stream. It's not a coronal mass ejection. Pretty cool to see it anyway. Plus the density dropped off quite a bit as well. So these are just the little dynamics. I also like going to the website Space Weather Live. It's a really, really good site. One of my old professors actually went to this site like religiously, and it's really good. It showcases the same stuff I showed you in a little bit more prettier fashion. You see their aurora oval, nowhere close to Wisconsin. So be very cautious on when you see things like this posted. KP index. So this basically just talks about how things are disturbed in the magnetic field, which is alive and well and very healthy around the earth. If it wasn't, we wouldn't have auroras. So when you see articles that claim the magnetic field is all wonky, it's not. It is intended to move. It's not switching polarity anytime soon. The sun's does. Every 11 years it flips polarity, which is why we have a minimum phase and a maximum phase. But KP index can be a threshold. It, I guess it's like a lazy way to look and see if we have storming going on, but it's an average of 3 hours. And if you're an aurora chaser, it just kind of shows how far south and how disturbed the magnetic field actually is. But otherwise, I did want to pop this up so we could look at some sunspots, but I can't remember where it is. Let's see here. Moon's phases. We have magnetometers, which show us disturbances in the magnetic field as well, which are great. All of these things come into play when you're trying to look at aurora. Let's see. Another X flare. This was May 14th. Yeah, you can see how cool that was. But let me go to auroral activity, solar activity, sunspot regions. So remember I was looking at that guy and this guy? Let's take a look at 4099. So this one, 16 sunspots. It's a moderate size. It's got some, properties that make it interesting. It's a beta gamma class magnification, or class magnitude rather, which kind of gives it, I would say, how do I explain this? That kind of gives it more complexity. The more of these beta gamma delta, beta gamma gamma, that gives it more complexity, which means it's more likely to storm. So that's the one we were looking at before. And then there's also, I believe, 4111 or 4100. This one has a very interesting polarity, so it doesn't look that interesting. 14 sunspots. The size is pretty big, but you can see as we look at it, lots of blues, so it's not that interesting. But anyway, just wanted to kind of showcase some of these guys. Maybe 4092 is interesting. This is a little baby guy, and that one's going onto the west limb. Actually, I should go. It's the west limb, which is this part of the sun, which is backwards from Earth. So if I've seen articles where they misinterpret east and west limb of the sun, the west limb is on the eastern part of what we would think Earth, but this is technically, it's rotating out around that west limb. So nothing that interesting sunspot wise. Maybe there's a couple of areas that get some flares, but the last big flare was on May 14th. But okay, just wanted to showcase that big old coronal hole. Let's show you that big coronal hole. That's what caused the potential aurora for maybe like Alaska and Canada. Didn't make it down to Wisconsin, but still pretty cool to watch.